Sixth grade science classes were recently working on a project-based learning unit called Design for Impact, Physics of Collision Engineering. Students designed and tested prototypes to improve safety in collisions to apply Newton's laws and the energy concepts in real-world contexts. WTV sat down with some of the students to find out how it went. Who am I here with?
Toby Wilson.
Chase Potter.
Angelo DeFeo.
All right, and what collision problem were you trying to solve, and what was your overall goal with this design?
We were trying to solve getting tackled in the rib area by absorbing the force of the tackle, and our design goal was to protect the player's ribs from getting injured.
And how does this prototype meant to work in the field? Who am I here with?
Jackson.
Haley. Isabel.
Lillian.
All right, and what problem were you trying to solve with this?
So like people, if they get hit in the chest, they won't get like injured severely.
All right, and how would it work in the field?
It would work in the field like if you do get hit in the chest, the ball will just bounce off and just go on the ground, so you wouldn't get, like he said, as hurt as some other players have.
Okay, how is your prototype meant to function in the field?
So Prototype 2.0 basically adds more padding than Prototype 1.0 did, and the padding absorbs the force of getting tackled.
And what was that improvement that you made from your first try to your second that you feel was most important?
Actually, let's choose this part.
One important improvement was that we added more padding to reduce the force and to make it safer on the field.
Who am I here with?
Aiden Lee.
Hi, my
Wyatt.
name is Caden Ford.
Say that into the microphone, please.
Caden Ford.
Michael Wallace.
All right, and what collision problem were you trying to solve, and what was your overall design goal?
Our design was a car to prevent the car getting damaged and thus car crashes by using foam to prevent damage to the car.
All right, and how is it meant to work?
Can you stop real quick?
Oh, of course.
Caden.
All right. Who am I here with?
Ella.
Maya.
Sadie.
And what collision were you working with?
With crumple zones and car crashes.
All right. And how would this prototype function to function in the field?
It would help people not get in so many crashes and wait.
Okay, it would increase the time of impact, which would then reduce the force on a person in a car crash so that they don't get injured as badly.
All right, and this is your second attempt. What do you feel was the most important change from your first one?
Probably so our first one we had a cushion that it was a rough cushion, and then it didn't work as well as we wanted it to. But then in our second one, we had a softer cushion, so the impact on the car wasn't so hard.
All right, which of Newton's laws of motion did you use in an application of this, and how does it apply?
Newton's second law, probably because Newton's second law is force equals mass times acceleration, and since we put the crumple zones in the airbags and the seatbelts, the crumple zone increased the time of impact, which then reduced the force, which made it a softer impact on a person.
All right, and what did you use to measure what measurement did you use, and what does it improve from your first attempt?
We measured the distance that the doll traveled in the car, so all the designs we made tried to reduce the distance that the doll moved.
All right, and what would you use for a hypothetical third attempt?
We would probably change our airbag because it was really rough and really small,
it helped, but I don't think it helped as much as it could.
All right, thank you.